Okay, we need to work on this. Circuit board. What seems to be the problem? We'll find out. All right. This is a classic example of a circuit board. It's got a input. Let's see, can we get this in picture? Yeah. Input, fuse, transformer. Then another fuse, bridge rectifier, capacitor, and voltage regulator. So this is all completely classical. We make a 5-volt power supply to feed the microprocessor. So a classic Philips with an old school EEPROM. The whole thing is running at 11.0506. Let's see. Can we read that? Does it work? Well, about 11 other glasses. 11.0592 megahertz. So, what else is here? We got a analog multiplexer right there. Where is it? Where's my screen? There, that one. Analog multiplexer. We got some analog inputs coming in here. We got some optocouplers to detect the voltage on L2 and L1, which is the speed switch. And we have some counter inputs because this is a dual motor controller board, and these counters measure the speed from the motor in pulses, and they output 0 to 10 volts on this analog output circuit. So that's a double circuit, 2 op amps. And what else is here? Well, we got a EEPROM. It's 24CO2. So a very small EEPROM for holding parameters. What we have here, let's put it into picture. Yeah, it is a transceiver for RS485 on these 2 connectors, so it can talk to some other device over a bus. This is not implemented, this stuff. This is 2 switches for bypass of the air, which are not implemented right here. It's a nice looking circuit board. I am not really sure what happened to it. It doesn't look bad, but I noticed there is an issue. Where is it? Is it on my screen? Where is it? Oh, here it is. Yeah. there's an issue here. This thing is toast, and there's another one. This one is also gone. And this is a 100 ohm resistor, and this is a 1K resistor. And this has been a little bit hot, and this has been physically damaged. So this is part of the analog output, I think. So if this is damaged, we might not have signal to the motor for speed control. We checked the fuse. Where's the fuse? Yeah, fuse was okay. Transformer, this is okay. Caps is looking fine. So looking fine. And let's continue with that. So you have a little impression of what's on the board. There's not much to it. So yeah. Okay, I'll just record this and see what I cut out. I did some flux on the board right here. I'm gonna wipe out this resistor, and I'm gonna take out that one. I'm just gonna use, I don't know, 30-watt soldering iron, heat it up and just move it around. Add some solder so we get some heat transfer, and there it goes. There it is. That one's gone. That's the 100 ohm, and this is the 1K version that needs to go. That's half of it. No force because no damage. So that's looking good. I don't know if it shows on the screen. Let's point to it. This one. Yeah, and no other one right there. Okay, I'm gonna get some resistors. Let's stop for a while. So I have the book of resistors, and I'm gonna take the 100K, the 1K and the 100 ohms. These are big resistors. Look, they're 1206 size. So yeah, that's what I'm gonna do. Yeah, only need one. So let's get some equipment. Where's the tweezers? Okay, got some heat resistant tweezers, ceramic tips. That's strange. Need to verify the values. Okay, I checked some values. This one is 100 ohms. I'm gonna put that in place. Oh, it's jumping around. It's hard to do. Trying to keep all the stuff in the camera. So that one's fixed. Is that visible? Yeah. Then the other one is 1K. 1000 ohms. It's hard to imagine how that could fry, but yeah. It wasn't broken, it just looking very badly. So it has been hot. So I'm gonna put a fresh one there. Well, for people playing at home, the 100 ohm resistor was labeled 1000, which means 100 multiplied by 10 to the power of 0, which is 1, which ends up being 100, and this is 1001, and that means that's 100 multiplied by 10 to the power of 1, which is 10, which makes 100 times 10 makes 1000. So that's how it works. Let's see if we can glue this in place with a regular soldering iron. Otherwise I need to turn up the hot air. But this is so huge, it might just work. Oh, where'd he go? There you go. Now let's flow this correctly, because it looks like something very bad now. Always add more flux. When in doubt, add more flux. So the solder will flow without oxidizing. Yeah, that might work. So I'm now gonna test this thing. So for who wants to know, this is part of the RepareerJeVentilatie channel. cooperation with Abari. Okay, let's get back to the circuit board and start testing.